Okay, guys. Okay, thanks. Okay, so this is how you draw the AM what you call signal. Okay, so some books they write like this. Sometimes they draw the peak first, but you start from the small, small, and grow, and you find the peak. Okay, so the period must be 20 microsecond. Okay, this is your carrier period. 200 microsecond is the period of the what do you call of the signal. So signal the 200 will go up and come down. Okay, so this is your AM. So whenever you get AM, make sure you find the period, the two periods, period of the signal and the period of the carrier. Okay, period of signal going to be longer, period of the carrier will be shorter. Okay. Okay, now so bandwidth for communications. I think I told you this already. Bandwidth are assigned by the government to impose the maximum signal frequency. Okay, the bandwidth assigned for AM, FM. The bandwidth assigned for AM is very small. AM only given 9 kilohertz, if I'm not mistaken. FM given a huge bandwidth just for purposely for a reason. The AM. Why they give a small one, just to send a sound signal only, but it broadcasts in a lower high wavelength or low frequency so that it can really spread. Okay, FM in other part, FM given a huge bandwidth so that it can carry lots of information, but channel in high frequency, so that it can carry lots of, it has a huge bandwidth. But one problem of FM is it really can't spread. Okay, that's one problem of FM. So limit fidelity of the music broadcast in AM, but permit luxury of stereo high fidelity broadcast by using FM. FM transmitted in VHF. The high signal frequency associated with the video broadcasting required a greater bandwidth. It's under UHF, EHF, and so on. So yeah, so AM the different wavebands. Okay, so AM stereo is only 15 kilohertz. The frequency limit for the music transmission is only 15 kilohertz. High fidelity signal transmission. That's all I need to know. Okay, finally, the advantage and disadvantage of AM and FM. AM, pickup noise. That's one bad about AM, pickup noise, because the signal is in the displacement variation. Displacement prone to interference. Interference is going to change the amplitude. So pickup noise. So it's going to be very noisy. I got lots of background noises. Lack of high frequency. Yeah, AM purposely sent by using a small frequency so that it has a huge wavelength, easily can spread. So there is a compromised quality. Okay. So AM transmission, the advantage of AM compared to FM is AM is cheaper. Okay, more AM radio station can share a waveband. Yeah, because the bandwidth is small, you can have lots of AM signals. Can be propagated over a larger distance. Okay, yeah, it can propagate a larger distance because there's a huge wavelength, really can spread. And AM transmitters is found to be electronically simpler and cheaper. So overall, low maintenance AM. Okay, but problem is quality. FM is the other way around. FM never really pick up noise, has high frequency, very high quality. The other way around. FM is totally the other way around. Okay, the number of FM stations going to be limited because it has a huge bandwidth. So it can't cover, FM can't cover big distance. You need a lot of amplifiers in between to amplify the signal, which costs money. Yeah, but electronically, FM is found to be more expensive. Okay. So this slide, this part, you have to remember the advantage and disadvantage of AM and FM. Any questions? No questions. Okay, let's go one example. One example of questions. AM, FM. Okay, look at this question. Okay. Describe what is meant by frequency modulation. So what is frequency modulation? Okay. The frequency of the carrier wave is altered in synchrony with the displacement of the information signal. 2 marks. So that's what you have to do. The frequency of the carrier wave varies in synchrony with the displacement. Keyword. Underlines this keyword. Displacement of information signal. Okay. That's your frequency modulation. Okay, now look at B. Come on, I give you 1 minute. Try to get an answer. What is the answer for this? B2, 1 and 2. A sinusoidal carrier wave of frequency 500 kilohertz. It's an amplitude of 6 volt. So carrier has 500 kilohertz and amplitude is 6 volt. Okay. Yeah. So carrier is the more high frequency one. Got 500 kilohertz and the amplitude is found to be 6 volt. It's a carrier. It is to be frequency modulated by a sinusoidal wave of frequency 8 kilohertz, 1.5 volt. 8 kilohertz. So the signal is only 8 kilohertz. 8 kilohertz low frequency, but the amplitude is how much? The amplitude is only 1.5 volt. 1.5 volt. Okay, this is your signal. Okay, the signal need to do frequency modulation with the carrier. Okay, now see the frequency of the deviation of the carrier wave is 20 kilohertz per volt. This is a very important information they tell us. So the frequency of the carrier is going to alter 20 kilohertz for every volt. Okay, describe the carrier wave variation in any. So after modulated, of course, it's going to be close, going to be further, it's going to be close. So what is the features of this modulated signal? How much is the amplitude going to have? So the amplitude is going to be same as the carrier amplitude, right? Carrier amplitude. Carrier amplitude is how much? 6 volt. So the amplitude is going to be 6 volt. It should be the carrier amplitude, right? Carrier amplitude. Because FM, the amplitude is going to be the carrier amplitude. Okay, how the frequency going to vary? 3 marks. How the frequency going to vary? So the frequency going to vary how much? Originally it's 500 kilohertz. Okay, the signal is 1.5 volt. Every 1 volt, the frequency going to change by 20. So 1.5 volt frequency change by how much? 30, right? Okay, 1 volt is 20, 1.5 volt going to be 30. So how the frequency going to vary? It's going to be 470, 500, 530 kilohertz, correct? Okay, 470 happens when the signal is at the drop lowest. Okay, then the signal go to the crest, it becomes 530. The signal is at the equilibrium, it becomes 500. Okay, so what do you say? The frequency going to change 470, 500, 530, or you can say it changed to 470, 530, and 470 back, one complete oscillation. How many times per second? The frequency going to alter 470, 530, 470. How many times in a second? What frequency these changes going to happen? It's going to be the frequency of what? The frequency of the signal. Signal 8 kilohertz. So it's going to be 8,000 times. The 470, 530, 470 going to happen 8,000 times in a second. Okay, that's the frequency alteration. So you see the answer. The upper limit is 530. The lower limit is 470. 470 is the trough. 530 is the crest. Again trough. So changes upper limit, lower limit, upper limit happens 8,000 times in a second. That's 3 months.
And so what is the, how do we get 8,000 seconds per second?
Why 8,000? Because why 8,000? Why 8,000? Because your signal is like this, right? Your carrier like this. So at this equilibrium, the frequency you're going to make is 500. Then when you go to crest, you're going to closer, become 530. Okay. When come to the here equilibrium, 500 again the frequency, and here going to be further, right? Here going to be 470. You see here, crest to crest, crest to crest. 530 lowest is 470. Come to crest again, here 530. So this is the carrier, and this is your carrier.
Okay.
So the compression to compression is how many times this appearance going to happen? How many times in a second? It's going to be the frequency of the signal, right? Signal going to make, like, it's going to go up and come down. How many times in a second? They say 8,000 times in a second, because the frequency of the signal is 8,000. So here compression
Where's the information of that?
8,000 times per second.
Yeah, but where do we get the 8,000 at where?
How to get 8,000, is it?
No, at where does it say that it is 8,000?
Okay, the signal frequency 8 kilohertz.
Okay.
Good idea, eh? So the signal frequency 8 kilohertz is the repetition, how many times per second for the modulated signal.
So that means the information signal's frequency will be the same as the modulated one.
The modulated, the frequency change. How frequent the frequency change? Yeah.
Okay.
But the amplitude going to be exactly same as the amplitude of what? Amplitude of the carrier. Amplitude of the carrier. Okay, so next, state 2 reasons why the cost of FM broadcasting in particular area is greater than that of AM broadcasting. Why FM costs a lot of money? Because it broadcasts in high frequency, so range is shorter, more amplifier, repeater, more amplifiers required, costs money, and the bandwidth is big. Okay, more radio stations required because shorter range, more complex electronic circuit, larger bandwidth required. Larger bandwidth also costs money, right? You want to get for the government to give you a large frequency range, you need to pay more money. So larger bandwidth costs money, because it's a short range. You need more amplifier, radio station, more radio stations are like acting as amplifier. So cost money because you need to build tower, and the tower keep the amplifiers, so cost money. Any questions so far? No questions, Okay, another question. So this is AM or FM? This is your AM signal, amplitude modulation. So you see, state the name of this type of modulation transmission. Of course, this is AM because amplitude has been varying. Say AM, amplitude modulation. Okay, then determine the frequency of carrier. How do you find carrier frequency? The short period or the long period? Which is the carrier? The short period or the long period? Long period is from the crest to crest, or the trough to trough. This is the long period. Okay. So which period gives you the carrier frequency? The T1 or T2? The carrier will be the T1, the smaller one. So frequency is 1 over the T1. So you need to read the one period from here. Quite small, so I couldn't see. Okay, I think it's 10 milliseconds. You have to check the unit here. Microsecond, I think. I think 10 microseconds. So 1 over 10 microsecond. So important is the short period. Short period goes for frequency of the carrier. Remember, the frequency of the information signal. The frequency of the information signal is 1 over T2. The trough to trough. This is your signal period. Okay. So that's the answer. So 1 over period. So carrier found to be 100 kilohertz. frequency of the signal found to be 10 kilohertz. Okay. Okay, now see, they're asking, draw a frequency spectrum of the frequency of signal. Okay, when the AM travels, how the voltage versus frequency looks like. So that the three arrows lah, this should be the frequency of the carrier. This should be frequency of the carrier plus the signal. This should be frequency of the carrier minus the signal. Okay. So carrier how much? Just now we calculated. The carrier is 100. The signal is 10. So what happened? The center will be 100. Here will be 110. Here will be 90 kilohertz. Okay, the frequency in kilohertz. What is the bandwidth? Bandwidth is the width of the sidebands. In this case is 20,000, right? 20,000 hertz. They want in hertz. Okay. So this type of carrier, how much of maximum frequency can carry? Maximum frequency can carry is 10,000 hertz. 10,000 hertz of sound it can carry. Okay. You want to with this bandwidth of 20,000 hertz, you want to carry a sound signal like an opera singer, a sound which is the pitch can go up to, let's say, 12,000 hertz. Okay, this bandwidth cannot be used. Okay, you want to carry a sound with 12,000 hertz. What is the minimum bandwidth required? Anybody? You want to carry a sound signal which has a maximum frequency 12,000 hertz. What is the minimum bandwidth required?
24,000.
Very good. 24,000 hertz. The minimum bandwidth required. Okay, minimum. Okay.
Oh, so that means okay.
Okay. So you have if you have a greater bandwidth, you can carry more high frequency signal. That means the signal is more quality. Because high frequency, like sound, high frequency, better pitch, right? Better pitch. So the vertical line is 100, the side bands is 90 and 110. The side bandwidth is 110 minus 90, so it's 20 kilohertz is the bandwidth. I tell you, this is the question, right? This question, I don't know how many times this type of questions repeated for telecommunication. The question is rigid. So, you know, it's something new, but the question is rigid. The same thing every year they're going to ask, what is carrier wave from this graph? Okay. So worth studying. Okay, so that's about AM and FM. Okay, so your phone signal now, the phone signal you are receiving should be FM frequency modulated. Should be frequency modulated. Now all the commercial transmission all are frequency modulated, and your phone signal you are getting microwave signal. Should be a microwave so that the wavelength is shorter wavelength, so that you can have a smaller area and very big bandwidth. Nowadays the bandwidth is very huge. Okay, so now you can receive from WhatsApp, you can receive videos and better quality imaging. 1K 4K videos I think takes time. Now Astro, your TV already have 4K videos, right? Because the bandwidth is huge. Okay, why the satellite signal have a greater bandwidth? Because nobody occupy. The lower frequency all already occupied. Now the higher frequencies to occupy, you need to have a satellite, because the signal going to pierce through the atmosphere because high frequency. So you need a satellite to deflect it. So you need money to have a satellite. So rich companies go for high frequencies because nobody occupying. They can have a huge bandwidth. No competition. Okay. Okay, good. So that's about first part. We have another 2 main part to cover. Okay, so next we have about 20 minutes. We can go through this analog and digital. Okay. Okay. So I believe many of you will come across the term analog and digital. Which is better? You have two types of signal, analog signal and digital signal. Okay, which is better for your, yeah?
Digital.
So you feel digital is better. Why digital better than analog? Now all are changing to digital world. They say digital world. But actually, digital is a photocopy of analog. Okay, the original is analog. Okay, digital is like a photocopy of analog. What I mean, live band, live band. You are listening to a music live band, and at the same time, you're listening the music by using CD. Okay, CD. Which is more quality, live band or CD? Like the pitch all changes very nicely, and you really can sense the variety of pitch. Okay, the pitch change seamlessly. Which is more quality, analog or digital? The live band or the CD? Anyone? Maybe some of you never experienced going for live band. Actually, live band is more clearer. A live band is more clearer because live band is analog. Okay, analog. CD is digital. Actually, CD is a recording the live band signal, and in such a way that nowadays the digital is quite close to analog. It's quite close. It's exactly like analog. The technology now, the photocopying is so perfect. Okay, but now why people go for digital if analog is like the quality? Why people go for digital if analog is very high quality? Because analog got one problem. That's what we're going to discuss. What is the problem of analog? Okay. Before that, what is meant by analog and digital? Analog signal has continuous value. It has the same variation with the time as the information itself. Analog, the signal voltage going to vary continuously. Very continuously, smooth curve lah. It can vary whatever shape it likes. You want to have 1 volt, 1.1 volt, 1.1 volt, 1.2 volt, any voltage can. If the opera singer sings with a high amplitude, so the voltage is going to rise. Any amplitude can. That's analog. Analog, the voltage changes continuously. Okay. Digital signal is a series of high and low values between the high and low values. It's just a high and low values. So digital record based on digital signal will be like a steps. It will be like a steps. For a while, let me show you one picture. Just for a while. Okay. Above here is analog. This sinusoidal is analog. Okay. This is digital. It's digital. Top is analog. On the top, the bottom is digital. The digital looks very ugly. It has like a step, few steps. Okay, it's a steps, a fixed value steps. This one is a smooth change. When opera singer sings live band, when she change the pitch variation can be heard quite smoothly. And loudness quite changed smoothly. But here the loudness like suddenly the loudness increases. Increases suddenly increases like there is a break. That's digital. Okay, so for time my experience so far when I describing analog and digital, you feel like digital looks so bad. Okay, but analog looks so good. This is the production. But now these steps, current technology, these steps is become very, very small. The steps become very, very small. Now the step is so small until what happened? It take this smooth shape. When you expand it, then you only know this shape is made of a very small steps. A very, very small steps. The width and the height become very, very small nowadays. The technology. So the digital looks like, as I say, very, what do you call, better photocopying now. Okay, like close to the actual analog signal. Okay. Okay, so that is analog and digital. What is analog? The signal voltage or the signal values varies continuously with time. Okay, continuously with time. Digital, it has a series of high and low voltage. What is meant by series of high and low voltage? This height, right? This height was calculated by a binary code. Use binary code to calculate the height. For maths, you learn binary code, right? Binary code made of how many numbers? Only two numbers, right? 0 and 1. 0 and 1. The image production of digital is made by this binary codes, only 0 to 1. So this is why it's called high and low voltage. Digital signals made of high and low voltage. Okay, high is 1, low is 0. Binary code. We will discuss this in depth. Okay, what is meant by that? Understand the definition. Analog, a signal which has a voltage or the signal value varies continuously. Analog, digital, it made of it made of signals with high and low values. Okay, discrete values, high and low values. 1 is high, 0 is low. Okay, so now let's see why analog, although is superior, is the original, but fail to perform compared to digital. Why? Because of this problem with analog signal. The problem with analog signal is this is your original analog signal. Okay, let's say in the radio station, when someone's singing the song by using a microphone, this is the microphone pattern electrical signal appears. When they air it, okay, they allow the modulation and they send the signal, modulated signal to in the air. What happened? By the time it transmit, it pick up noise from the surrounding. What happened? It become noisier. The wave, right? This is a wave, right? When wave travel for a further distance, what happened? The amplitude gets smaller, right? The intensity drops. That's why the intensity getting smaller. Okay, but it already picked up noise. So this signal periodically will be amplified. Let's say from Subang Jaya, there is a radio station sending this signal. Okay, at Puchong, they put a tower. They place a tower, a radio station tower, to get this signal and to amplify the signal to send it back to other places. When they do amplification, what happened? This is what happened. What happened to the signal? The signal has been amplified, but not only the signal has been amplified, the noise also amplified. The noise also amplified. So the analog signal pick up noise. Okay, that's one big problem. Analog signal pick up noise, but noise is amplified with the original signal during amplification. That is the biggest problem. The noise will be amplified together with the signal values. So if you do 10 tower with 10 times you amplify it, the signal get more noisier. So when it more noisier, once get into your phone or when get into your TV, the image is going to be very poor quality. It's going to be very highly noise, not that clear. Like Extro was broadcasting before HD. HD is digital. HD is digital. Before HD, the AV signal. AV signal is actually analog. And the Astro broadcasting the AV signal, the image you are getting is not that clear, right? HD and AV, I think HD is more clearer because HD is digital. Okay, yeah. So that's the problem of analog. Why analog not good compared to digital? Because analog pick up noise and the noise is amplified together with the original signal during amplification. Okay, what is meant by noise? Noise means unwanted random power. It's unwanted random power. We don't want that power, but it interferes. like a motorcycle sound. A lot of sounds are available surrounding one. So the unwanted signal, unwanted random power added onto the original signal. Okay, so become noise. Okay, one source of noise is the thermal vibration of atom. Okay, thermal vibration of an atom vibrates. Okay, you give out EM radiation. The EM radiation go and interfere with this. Okay, medium that signal is passing. So you have a cable, coaxial cable. You send the signal. What happened? The atom vibrates. The atom going to interact with the transmitting signal. So noise going to that's called noise. Okay. Yeah. So remember, noise is unwanted random power added to the original signal. So next, attenuation. Attenuation means what? Gradual reduction of the signal power. When the signal is sent, the power of the signal will going to drop because lose intensity, right? Intensity drops. Intensity drops. In telecommunication term, they call attenuation. Attenuation means what? Reduction in the signal power. It's called attenuation. Attenuation happens for all the signals, not only analog. Digitals also experience attenuation. So how do you prevent attenuation? Not to say prevent. How do you manage attenuation? By having a amplifier in between. Okay, so you need to amplify the signal to overcome this attenuation. The signal will attenuate, you amplify it back, get it large. Then after a shorter distance, it will attenuate again, put another amplifier, enlarge it. So that's how
is attenuation damping?
I can say like that. Yeah.
Why?
Damping is more to oscillation.
Yeah, but this one is like, oh, okay, I see. Yeah, both are wave, but it's but this wave is not like repeating pattern. Yes, different. Yeah.
The term attenuation is used in under telecommunication studies. Under telecommunication, they call it attenuation. The signal is attenuated. Okay, they won't call signal is damped. Normally, oscillation is damped. The term, yeah, like your phone signal. The phone signal can't reach in your living room. You have the Wi-Fi router. When you go to the room, you can't get the signal because we say the signal is like attenuated, reduced. Okay, attenuated.
Okay.
So lose power. Okay. Okay. So now advantage of digital. Why digital is better? The digital signals. Okay. The digital signals only got two code. It only got two code, 0 and 1. 1 is the high voltage. 0. This 0. 0 1 0 1. 0 1 0 1. The code. When it transmitted, what happened? Digital code transmitted. Attenuation will happen. You see this attenuation. The power 1 drop to lower, attenuated, and also pick up noise. There is a noise is picked up. But when we do regeneration, normally digital we say regeneration, regenerate back the signal. What happened? The regenerator only know two values, 1 or 0. So the value which is intermediate value will be brought back to 1. Okay, the one quite close to 0 will brought back to 0. So you retrieve back the signal 1010 you get back. Okay, but analog, the amplifier, right? When you amplify it, the value can have any value you like. It can have any value. So the noise also will be amplified. Okay, noise also will be amplified. But in digital, you can't have a rough surface. All when regeneration happen, all must go to 1. So it will be flattened because in regenerator only understand two code, 1 or 0. So anything fluctuate, all it bring to 1. So you get back the signal. So what is the advantage of digital signal? Is the digital signal pick up noise? Yes, digital signal pick up noise like analog. But digital signal can remove noise when regeneration. Can remove the noise. It can dump the noise. So your signal, when you transmit it, you pass through 10 regenerator. your signal won't get noisier. Your signal going to be looks like the same as how it was broadcasted in the station. That's why the HD channel all so super clear, because the noise has been removed successfully, because the signal transmitted through digital. It's a digital signal. 1010. Okay, so a digital signal can be transmitted over a very long distance with regular regenerations without becoming increasingly noisy, as it happened with the analog signal. Analog signal get noisier. The attenuation addition to the noise also happened to the digital signal. Don't think noise never interact with digital. It happens, but the noise consists of typically a small fluctuation of, they are not amplified by the the noise not amplified by the regenerator. Okay, so it filter out the noise. So that's the success story of digital. So digital looks like a better signal than the analog signals, because it can remove noise from the signal. Any questions? No questions, eh? Okay, that's the introduction of analog digital. Analog digital is better because remove noise. Okay, able to remove noise through regeneration. Analog, although its quality is good, but when transmission, noise is picked up, and when do amplification, noise also amplified. So the signal get noisier. Okay, so what is analog? A type of signal where the values changes, the signal values changes continuously. Continuous values. Analog signal has a continuous values. It has the same variation with time as the information itself. The values changes continuously with time. Digital signal is a series of high and low voltage and no values in between. It's called digital signals. Okay. Okay, the digital signal will not only remove noise, it got more advantages. It's a long list compared to analog. Another one advantage is, further advantage is, your digital signal can put extra information, can code, can encrypt data. Can encrypt data. Encrypt means what? You can put password. Okay, like Astro, they can block your, they can give you a password. Okay, if different channel you want to close it, you can place password to block it. So digital can do that. Okay, the extra information, extra bits data added to the transmitting system. This extra data code to be used by receiving system to check for the errors and everything. So digital also is reliable and cheaper to produce, it seems, compared to analog circuit. Okay, same thing, like you see your digital watch and analog watch, which is more expensive, digital or analog? Digital watch is more cheaper, right? Analog is more expensive. The needle, the gears inside, okay, more metals required, so expensive. Digital is cheaper. It's cheaper, and it's reliable, not easily breaks, okay, malfunction. So yeah, digital circuit more what do you call, more advantages. Advantage of transmitting signal to digital signal. Can encrypt the data, reliable, cheaper. These all are what do you call, secondary benefit. The main benefit is, of course, this digital can remove noise when regeneration. So that's the biggest plus of digital. Nicholas, any questions?
Answer, if for digital, it's binary, right? But how do we get the different amplitudes for different noise? Not different noise. I mean the voltage.
That's what we're going to do next class.
Oh.
So it's, yeah, this is what we're going to do. How they reconstruct different voltage, how they have a different code. We will be discussing this. I don't think so. I can, because it takes time, around maybe 30 minutes. Maybe the next class we can continue with this. How digital get information from the analog and how it formed the graph again. Okay, so we stop here for today. Okay. Okay, so those who missed the what do you call the you missed the workshop that day, okay, Shiki. Yeah, you can in the in the online class, right? In the online class seniors, you see here the workshop paper 4. This is the last year's paper 4 workshop, okay, handled by me. So this workshop recording is exactly same as the this year's one, but only different is the recent paper analysis is missing. The recent paper, the 2020 winter paper analysis is missing. Okay, but I think you already have the soft copy, right? Other than that, it's the same file. So you can go through this video, the informations. Okay.
Okay.
Okay. So I think tomorrow you have a paper 5. Tomorrow or today, paper 5 workshop. Tomorrow, right? Try to attend. Okay. Thanks. See you then.